What's up, people, and welcome to another episode of Developer Habits. My name is Ketmar, I'm a full stack engineer from Estonia, and today we are going to talk to Anastasia Marchenkova, who's a fellow YouTuber talking about interesting subjects like quantum computing and software development. In this interview, we are going to find out about Anastasia's journey of becoming a quantum computing researcher and a software developer. We also focus on how to learn and explain and teach complex subjects and how important it is to take care of yourself. Before we jump to the interview, make sure you have already hit the subscribe button, and with that said, let's start. Hi Anastasia, how are you?
Hey, nice to talk to you here.
I've been following your journey a bit through your videos on YouTube, and it's just amazing. You talk about a variety of topics like software engineering, which well, I'm personally really interested in, but you also talk about a really complex subject like quantum physics and quantum computing and so on. So maybe you can tell us a bit about your channel and your own background.
Yeah, definitely. So my background started, I guess my interest in tech really started when I was a kid. So my dad is a professor in physics, or was the professor in physics at the time, and I spent a lot of my life growing up following my dad around in the physics labs. So I was born when they were in undergrad, so my parents were very young and didn't have a lot, right? So we went and I spent a lot of time in the labs with my dad when he was doing his PhD in Leiden. And then when he's doing his postdoc at Berkeley in California, that's how we moved to the States. So English is my third language at this point, but I was always around technology and I was always around people that were very passionate about the topics that they were studying because a lot of them were PhDs and they had chosen to go into a very small, narrow topic. And I think it took until I was about 13 years old to realize not everyone gets PhDs and there are different paths to life. You know, some people don't even get college degrees. I didn't really know that. But I was always kind of exposed to these topics. And in high school, I went to a specific magnet high school for math and science because of the robotics team. So my dad again brought me to this high school to take a look at what was going on there, and said, you know, it's your choice if you want to apply, but they have cool robots that you can play with if you want to do that. And of course I was so excited about that and I applied, got into the school, and I think that was the first time I felt kind of really at home because I was surrounded by so many nerdy people who were again very excited about what they were doing. Ended up graduating early from high school because I got bored with that. So I graduated after 3 years instead of 4 years, just because I enjoyed what I was doing. I was already very ahead in math and science at that point, and I realized that if I'd stayed an extra year, I'd be taking most of my classes at the university anyway. It's like, can I just go to university and actually figure out what I want to do? So my journey there, you know, I went to an engineering school, so I kind of knew I wanted to stay in the technical side, but I declared as a computer science major, and then I switched to biology, and then I only switched to physics. And it took me a little bit to explore what I really wanted to do, and I was very kind of conscious about trying a lot of things and finding opportunities. And you know, through the robotics team, through the courses I was taking, I was kind of spreading my um like class load around and like different types of topics to figure out what I wanted to do. And I landed on quantum computing. And the reason I landed on it wasn't any kind of big momentous thing or something like that. I just wanted to do research in physics. I'd already been doing research in chemical engineering on transdermal drug delivery. And I thought that was pretty cool, but a lot of the work was kind of, I want to say, mechanical, in terms of like the experiments weren't fundamental science and we were building cool things, but I wanted something a little different. So I started emailing professors in the physics department, just being like, hey, can I do research with you? And the first one said no, and I think it was a biophysics lab, and they wanted people who were already in their third year, fourth year studying. The other one, the second one, I actually wrote the email to. They said yes, and that was a quantum telecommunication, quantum optics lab. And I just went into it right after that. So it wasn't like a huge like picking of the field or something very deliberate there. I just kind of decided that I wanted to do research and I picked something because I knew the professor was great, the advisor would be really good, I'd learn a lot, and I decided to kind of get good at it, which I think is a lot of philosophy that I have in my life due to some of these books that I really like. So Cal Newport is one of the authors that I read a lot. And one of his blog posts and his books, he talks about passion being overrated. And
Mhm.
passion is about just being really good at what you do. And so I've always kind of taken that philosophy in a lot of things, just become really good at this thing. And obviously there has to be some interest in it, I knew I wanted to be in the field of math and science, I would not be passionate about English literature or something like that. That's just not my strength, right? But I picked a field and kind of went into it and decided to become good at it. So then, I got good at quantum computing. I got very lucky that I got to do 3.5 years of research in quantum telecommunications, quantum optics, just an undergrad, which is amazing for an undergrad to do that. I took a little break in between graduate school and undergrad, actually, and I started a company, which again was one of those things where I had an opportunity. It came to me. I thought, well, I'd never considered doing this, but I would learn a lot. This is something I've never done. It's something I'm interested in. Like, let's see if I can do this, right? And then ended up going back to graduate school, moving into superconducting qubits. So at that point, I already knew I had the background. I kind of transitioned a little bit because I was doing neutral atoms before and transitioned into superconducting qubits. Well, in graduate school, I was kind of looking for a new field. I was either trapped ions, superconducting qubits, and ended up dropping out, going into industry and quantum computing in superconducting qubits. So then I kind of started honing everything into that. And for my social media stuff, in the end, I actually started around graduate school time just because I did not see a lot of resources at the intermediate level for quantum stuff. And there are a lot of questions people were asking me, and they had a lot of misconceptions because of all the pop science articles that were out there talking about quantum computers work by solving all possibilities at once. And I'm like, no, 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 that's wrong. But then the other side of it were these academic papers that only physicists can read. And like they're meant to sometimes be hard to read. And there's nothing in the middle. So I said, I'm going to write an article about, I think my first article is like, so when can I play video games on my quantum computer, right? Because that was a big question that I got and kind of took a lot of those misconceptions and concepts into one post. And I think I got something like 20,000 views on it in just a
Oh,
couple
wow.
weeks. And I was like, okay, people care about this. Like, people think it's interesting. And from then, since then, it's kind of spiraled. Like, I kept writing my blog. Video was always scary for me, English being a third language. And even though I spent a lot of time here, some people think if you have an accent, they don't like it or something like that. I see that a lot on my YouTube channel now. Like, people get very pressed about certain words I just don't pronounce in a very American manner. And so, yeah, video was just something that I never thought I'd do. But this year with a pandemic happening, I was alone and bored and had all the spare time. And I said, you know what? I'm going to try doing this YouTube channel. It actually started when I started on TikTok. So during the pandemic, I said, you know what? I'm going to post twice a day for 30 days on TikTok talking about quantum and software. And after those 30 days, I got like 12,000 followers, which to me was amazing for such a niche topic. People kept asking questions, and I was like, I can't explain this in 60 seconds on TikTok. I'm going to have to make a YouTube video on it. So then I started my YouTube channel, and that spiraled. And now I have a bunch of subscribers there. So I just keep going.
What a journey. Let's go back to the beginning, to the let's say high school and going to the university and those times. As I understand, you were quite good in those like physics and mathematics and stuff like that. Was
Hmm.
it something that just came to you? Was it something because you were always surrounded, by, as I understand, your parents were also doing science. So, how much do you believe was it the talent versus something that you really had to work for?
I think it was a mix of both. And I think a lot of people say that. It definitely helped to have parents that knew about math, right? But the way things are taught in the US versus Russia is also very different. So sometimes that didn't help, right? Because sometimes in the US they want you to solve things in a certain way and that's your homework. But sometimes that gave me an actual different perspective on the math, right? For me, it was all about kind of I think my upbringing in terms of like reading. So again, because I moved to the US when I was 7 and I didn't have a good grasp of the language and I was kind of like the weird Russian kid, I spent a lot of time reading about different topics and being able to take those topics and kind of compress them into something I understood even at, a young age. I remember at 12 years old, I actually finished reading all the books in my house.
Oh,
Like
wow.
pretty much everyone, like every book that we had there. So my dad gave me a biochemistry textbook from the university to read, and I was like 12. And I think I got through like 100 pages before my mom caught me. And she was like, no, we're gonna like go actually buy you books. Like, this is ridiculous. So yeah, I think it was a mix of that. I do think I had some natural aptitude towards it and some sort of like maybe there's a brain structure thing, something there genetically, but I also spent a lot of time doing things I think that would help with that, doing robotics in high school, being able to practically apply those things. So I do know I'm a little worse at math when it doesn't have the direct application. And so when I did spend more time in biology doing the math or, in robotics, that math came to me a lot easier than it would have in a pure math class, if that makes sense.
Hmm. It's actually something that I personally have felt, and I believe there are many children being taught about, let's say mathematics, and they're given some kind of formulas and said, okay, you have to know this formula. But I remember when I was in school, I was always like, I can't move forward. I want to understand how does this formula work? Why does it work that way? But in in school lessons, you just have to go through it, you cram the formula, and you just apply it. But
Yeah,
people who
definitely.
are curious, I would say, want to know more, and I guess that's where also the application part comes in. If you whether you can code robots or you can, I don't know, build software or whatnot, that you can apply some kind of knowledge that you have acquired.
Yeah, definitely. It's that physical intuition, I think. Taking the math equations and, throwing the ball, right? That's why it's like the physics problem, right? You see exactly, well, you apply more force, it goes further, right? And being able to do the math and have the building that intuition there with like real quantities or something like that, I think really helps. And actually in high school for my senior project, I did this curriculum study. So I went to the middle school and I decided to spend my semester building a curriculum to teach middle schoolers how to program. And I tried a few different methods there and we did some like mini research in the classroom to understand it. And like all the kids that were working with like the Vex robotics, the Lego robotic stuff, they just picked it up. They built that intuition so much more easily because they can connect that with the real world versus the, plain theory.
Hmm. I see that this, let's say, teaching has been really important too. Like, if I'm correct, your startup that you founded was also connected to teaching. Yeah, and
Yeah, it was
you
related
mentioned.
to educational technology. Yeah, it kind of what it ended up pivoting into was kind of the service to help college students find jobs because that was a problem as a physicist. I felt like I had a lot of things that I could do, but maybe I couldn't pass an interview for a software engineer, for example, because I didn't study all the theory, but I knew I could program. So one of our thoughts was, well, what if you could help students build the skills to get the jobs, out of college? Because college doesn't always prepare you for those jobs, right? And this was the same year that Udacity and Coursera were being founded. So online education was starting to become a bigger thing. And so what we did was we could basically take your resume, parse it, and say, okay, well, you want to be a software engineer at Google, but you don't know Java, for example. Like, here's a course for you to learn about Java and kind of connect you on either side to employers that needed those skills as well and help you kind of build up your skill set, the practical skill set.
I guess teaching is one of those topics where if firstly, you can have a huge impact on people when especially when they come back to you and they say that, hey,
using your platform or using your courses, I was able to change my life, and it's so like fulfilling to do.
Yeah, that's been the most rewarding part of this whole social media journey. I have this one person that wrote to me a couple months ago, and he told me he had dropped out of college because he never found anything very interesting there. And my videos helped him realize how excited he was about physics. So he was going back to college and actually going to transfer into the physics major and finish his degree. And that felt so good to like have that big of an impact on someone's life. Like they found something that they could potentially be passionate about, you know?
You also mentioned that now that you are also a YouTuber, but you teach topics, for example, let's say quantum computing, which to me seems really complicated topic. And I've also done my I've read in Wikipedia about, I don't know, what quantum entanglement means, for example, but I don't really understand those topics. And you somehow have made it so easy to consume through your videos. And I can imagine that it's not just something that just comes from the top of your heads. I assume that there's lots of work in the background in order to make it feasible for, you know, people who don't know about those topics so much. So maybe you can talk about more about how firstly you consume knowledge and also how you make it simple so that others could also understand it.
Yeah, definitely. I think I have two approaches depending on what I'm doing. So for my YouTube videos, yeah, I want to say probably half the work goes in before I even turn on the camera and start filming because I am doing something that hasn't really been done before in terms of the level I feel like I'm approaching things at. And so I'm very conscious this way of defining terms as I'm using them because on one hand, you do have to know the term eventually. On the other hand, if you have too many terms, like that obfuscates the meaning, right? And I think that was a big frustration of quantum, right? You talk about all these topics and you have all these words for certain things, and they're really not that difficult of a concept, but nobody ever tells you that up front, right? So you're going to the Wikipedia, like the Wikipedia pages are not for the average learner, right? I mean, it starts throwing out, 10 crazy buzzwords up front and you get lost there, right? So this approach that I did when I worked at Coursera and I actually spent time my job was to train academics on how to do this. So I applied that to my YouTube channel, right? And it was always like define, build on the knowledge and define things up front. So that's how I'm approaching kind of my YouTube channel in I'm starting at kind of the basic topics. I always redefine a lot of things, even if quickly, even if I can't dive deep into it, but usually I have another video that I've already covered and I can point to and be like, here's a deeper explanation. But, one thing I think about a lot is coherence time. That's the length of time quantum information can be stored. And no one ever defines that ever anywhere until you dig into it. And I try to every time I mention it, at least in the video, it's talking about a lot. It's like, oh, coherence time. So someone understands the term, like now they've heard the term. I define it quickly, and maybe point them to another resource where they can dive in more. So that starts like building up these little keys of knowledge. So I found the same way, as I'm doing that for my YouTube videos. With my YouTube videos, because I already have the research, it's about taking those complex things and breaking them back down into simple things and still being accurate. So there's a lot of work that goes into that because honestly, sometimes even researchers in the field, you ask them a simple question and they're like, I don't know, because quantum is not intuitive like classical mechanics is. Our world is classical, so we can intuit things. Quantum is not always intuitive. So I remember researching something for one of my video posts and I like messaged one of my friends who's a postdoc in quantum error correction. And I'm like, this doesn't make sense to me. And an hour later he messages me. He's like five of us researchers are on the floor with a whiteboard right now trying to figure out your question. And I thought it was like a simple basic question, right? But it wasn't. I mean, it was, but it was just like it's not intuitive. So you have to think about it a lot to understand what's going on there, right? So that's what I do. That's kind of my process there. And I apply that to new things I'm learning as well. And I think what I recommend to people and how I do it is I don't always worry about understanding everything super deeply. So I think some people approach it like you see a sentence with 10 buzzwords, right? And then you're like, okay, Hilbert space, like
Mm.
let's dive deep into what that is. Sometimes I feel like it's enough to just hear the term and understand a basic, maybe not fully accurate understanding of it, just a metaphor to just move on and start kind of connecting all the dots together. So when I actually moved into software engineering, I didn't know a lot of the stuff of software engineering, and taking a big coding book and going through it, well, you can't absorb that all that quickly. The expectations there I had for my job was to kind of start coding pretty fast. And so could I go through 300 pages and know them perfectly at the end of a week? No, I couldn't. But what I did was I exposed myself to enough of the topics that I was able to, when I had to use them later on, I'd heard it before and I knew where to look. So one of the examples was in my job in software engineering, I use Golang. And so Go routines and channels are a big part of it, but it took about 5 months into working at that job for me to actually run into something where I had to use Go routines and channels, right? So I understood that at the beginning and I kind of understood what it would take to succeed. And I was like, no, like data types are more important, learning the code base, learning Google Cloud, prioritize learning that more deeply because I had to. Go routines and channels, I'm going to skim it. I'm going to have a surface level understanding. Once I hit it, I'll deal with it at that point. And I think that helps for me because, approaching quantum as a whole topic, that's 4 years of undergrad plus 5 years of PhD for a lot of people. Like, you can't compress that into a week. So, my recommendation there is always project based, right? Like, go through things, even if you don't understand the first time, like, go through it, write down what you know, write down what questions you have about it, start researching those questions. Like, oh, I don't fully understand how this equation connects to that, dive deep into it. Oh, I don't understand this term. Okay, now dive deep into it. Like, keep working through. Every time you hit that barrier, then dive deep into the topic, right? Um, that's my path. That works well for me because it kind of, it's more of a just in time learning technique, and it makes me, I feel like, more effective instead of like waiting until the end of having studied, multiple courses to be able to do something, and that also keeps me motivated.
Hmm. I guess I could see that it really connects to the topic we spoke about before regarding applying mathematics, for example. Again, that
Yeah.
you gain some kind of knowledge, and if you can apply it, then it kind of clicks to you because there's an actual need for that.
Yeah, definitely. And that's kind of how I'm structuring my channel. A lot of people are just saying like you need all this background to do quantum computing. It's becoming obvious to a lot of people you don't actually need full 2 courses on quantum mechanics to do quantum computing. Of course, if you want to do research on it, yes, you do need quantum mechanics, but to run a simple circuit, you don't need, a year-long course in quantum mechanics. So let me start from that because I also think that gets people more excited about the topic, right? You have an impact much more quickly, and then you can go back and start building, the background that you need to actually get to a higher level. So that works out for me. I think it works pretty well generally for self teaching, and obviously on my YouTube channel, that's so far working. So we'll see.
Yeah, I mean, I was doing the background research. Yeah, let's call it background research, and I was watching your videos, and my girlfriend saw one of the videos where you're explaining like the basics of quantum computing. And she was like, "Oh, that actually makes sense. I mean, I can follow and I can understand." And
That's amazing.
I, I really see you as a translator who translates those complex ideas into something that's more feasible. So
Yeah.
that's really cool. But
Yeah, it sometimes gives me a little bit of an existential crisis because, like, I'll run into something that I know is true experimentally, but I can't put it into words yet, and I'll just sit there and think for a long time, like, "I know this is true. How do I rebuild that intuition? How do I make that intuition?" Because, honestly, in my first quantum mechanics class, the professor, I remember the first day walked in and said, "Remember everything you learned in classical mechanics? None of that holds true now," you know? And you're like, "Oh, okay." Like, this is a lot to deal with at that point, and, yeah, quantum is not intuitive, right? So, I have to think very hard about how to try and build an intuitive explanation for it that actually makes sense. So, yeah, it's a lot of work, but I think it's very rewarding, and it helps me, right? Because now I'm able to recall things better or explain them in a more clear way all the time because I've done the work on building that intuition.
Hmm. I must ask, who is your main target audience for your YouTube channel?
So far, it's just people who are interested in tech and want to get into it. So, as you noticed, my channel is a little more kind of split. It's a little more split between quantum, videos have done really well, but I do want to expand a little more into tech, and I just want to reach people that may not have these resources or good professors. So we talked a little bit about, in university, you don't always have professors that want to teach. And now with the internet, you can have courses, you can have people online teaching you that are super excited about it. So I want to people to have that opportunity to have that. So that's kind of my target audience. I mean, my vision for the channel eventually is, maybe this sounds kind of very broad and aspirational, but how we can make a better world with technology. So I do want to expand a little more into software engineering just because that's my background and I do that a lot. So I definitely want that to be a part of it, because the reason I actually switched from computer science to physics is that I wanted to use computer science as a tool, but I didn't want to study it just as its own field. Like, I knew computer science is a very important thing to have in my skill set. But yeah, I didn't want to just focus on it. I wanted to apply it to something. So physics or biology were the two things I was looking at. And that's kind of why when I integrate the software engineering and, in the end, I'd love to do, these like simple explanations on, battery technology, solar energy, like lab grown meat, deep tech stuff that people feel like there's not a lot of resources for, that there's not a lot of like intuition for and things like that, and keep going into that. And hopefully, yeah, with quantum computing, people talk about like, oh, Shor's algorithm is going to destroy the world, right? But there's so many good things that quantum computers can do as well. So kind of building this out right now and talking about the different algorithms. I'm preparing a video right now, like 5 quantum algorithms that can change the world, and like one will change the world in a bad way. But the other four are actually really great and can apply to a lot of problems. So I do want to have that balance and talk about kind of more of the vision. Yeah.
Yeah, I was just thinking here, like if I would hit even more subscribes. Like, I really genuinely believe that it's important to have smart, intelligent people explaining complex topics in layman terms, so that I don't need to know everything about quantum computing, but when I know there's a person behind talking about those topics, and he or she has learned about those topics in the past, then I can kind of take it as my own knowledge, or I can, you know, make my decisions based on that knowledge. Yeah.
Yeah, so for directly for quantum computing, I think there's a very interesting thing that if quantum computing does become like very mainstream in 10, 15 years, there are not a lot of physics PhDs in the world, right? There's not a lot of quantum computing PhDs in the world. So my vision there is we are going to have to abstract away some PhD level details because we're going to need computer scientists to be able to work with these systems and not have to get a physics PhD, right? We're going to have to talk to people in different fields and go, well, we can apply quantum to your problem. They shouldn't have to have a PhD in physics to be able to, map their problem to a quantum computer, because I don't know what we calculated at that point. We're talking somewhere. We're like, how many people do you think in the world like truly know how quantum computers work? Like 10,000, maybe, like at a certain level. That's not enough to, if there are a lot of quantum computers in the world, right? To just sustain, maybe full-time engineers working on a quantum computer, 5 to 10 of those, plus like people to do algorithmic research, but then, software engineers to build up the coding languages and like build other tools and features, like that starts adding up so quickly. And then you want people to actually use it, right? So yeah, there's a lot to do, I think, on the education aspect, and I think that's where we're failing, and I think that's where my channel is succeeding, because I started seeing this gap of knowledge. Because in industry, what would happen is you'd walk up to a company and say, give me a problem that my quantum computer can solve. But they don't have the intuition to know what problems quantum computers can solve. So it becomes this weird thing where they're like throwing out ideas and you're like, no, no, no. And I'm like, no, we have to teach them to build that intuition to map problems to quantum computers. That's what they need to know. Then after that, they don't need to know how the hardware works or whatever. They need to, what level can we get at, and we can keep working on abstracting those details away. So right now, I work some with people talking about like how do you map problems to qubits, and I think on my video on quantum annealers, where I actually talked about like, hey, here's a math equation. It looks like this graph. Oh, this graph looks like the qubit hardware. I saw so many comments, people being like, oh, I finally like understood it. Like it was always this map equation and like qubits do magic, right? And I was able to connect that to, the equation to the graph to the qubit topology, and it clicked to people, and now they're able to more see like, oh, okay, so if I have an equation like this, I could see that in my field. I've seen that in my field. I can map it to, quantum hardware. That's the intuition we need to build.
Because I started drawing connections to machine learning. Because if we look at machine learning at the moment, I don't know, if you want a investment for your startup, just use the buzzwords machine learning. We utilize
Yep.
machine learning, but people, I mean, business people are starting to understand more and more what are the actual problems you can solve with machine learning. And I
Right.
personally, as a software developer, again, I can use like TensorFlow, which is just a package around so many more complex concepts, but it's all like abstracted away so that I could utilize. And I guess the same thing has to happen at some point to quantum computing.
Yeah, definitely. And there's a lot of tools that are starting to pop up. The problem is that I believe they're going to have to be hardware specific just due to the nature of quantum computing. So a lot of these things that are coming right now are good like toy problems. But for example, there's TensorFlow Quantum right now, which is something people have been asking me about a lot. And yeah, they're starting to abstract those details away. Right now, it will probably only work for the Google quantum computing systems, right? But maybe at that point, if there's more hardware that comes out and works, they can map that. But that's a lot of additional work, which again the developer shouldn't have to know.
Another thing that popped to my head is as a software developer myself, I sometimes find myself battling between, wanting to focus more on the details of technology or going really deep into some technological topics versus uh, taking more time to explain concepts to myself and to others. Do you have some kind of similar thoughts in your head, like regarding teaching and focusing even more on some certain topics?
Well, I think for me, a lot of the work that I do kind of hits both, just because through the teaching, I am in the deep technical details and I do have the background to get into them. And so sometimes I'll read a new paper and I'll have to spend a lot of time figuring that out. And then I bring it back out again to the teaching, and building that intuition up. And that helps me, again, like if they're complex topics in the papers and getting into those deep technical details, like pulling it back and having those simple layman's explanations, even in my own head, makes it a lot easier. I don't think I have a huge battle on that, just because my life right now is spending more time towards the teaching aspect of it, because I feel like I have so much to cover right now of the things I know already, that all the things I don't know, I'm just like, you know what, we're gonna kind of toss. I mean, obviously I have to do some research on every video that I put out, but it's more minimal. I think someone asked me about that one of my comments. They're like, how long does it take you to do this? I'm like, you have to understand that I already have some background in this, so jumping to that deep technical level and then jumping back is a little less of a deep dive than someone that comes in from nothing. But I always focus kind of on the shallow first, and that's kind of how I mentioned for software engineering, right? That's my approach, where it was kind of do a major sweep first, then start hitting the things that I need immediately, and then wait to get into deep technical details once I need them. And so I kind of do that approach um, more more often, just because it gets me to where I need to go faster. Because I think for coding, you know, 80% of what you're going to use every day comes from 20% of the content. Introductory things like you need to know your loops, you need to know your data types. And then, one day you're going to run into like this memory allocation bug and you're like, okay, I'm going to sit down. And I did that like a couple weeks ago. I had this weird bug and I sat down with a book and I was like, okay, it's time to dive deep into this topic because I can't figure it out. And so majority of my time is spent on kind of the shallower, I think, side because that just accelerates me faster.
You mentioned the word time many times. So as you have tons of things on your plate, like creating a community, but also working as a researcher, can you maybe talk about your time management philosophy? How do you manage time? What are your like daily rituals, and how do you even avoid burnout?
Yeah, that's a hard thing to do. I have not been great about avoiding burnout in the past. And 2 years ago, I read a book that completely changed how I think about it. It's called Peak Performance. And you think it's going to be like a super motivational book about time management and habits and everything, but it wasn't. It spent probably, I think, a third to half the book talking about resting. And I realized at that point that I was not resting properly. And that was what was causing my burnout. So, I would work myself to the bone every week. And then on the weekends, I'd be so exhausted. I just lay in bed and not do anything, right? That was the wrong type of rest for me because by like 3, 4 p.m. on Saturday, I get like depressed and I'd feel like I feel like a slob. I've done nothing. I haven't put on real clothes. Like I feel awful, right? And they talked about that, right? Like I wasn't getting anything out of that type of resting situation. And I started thinking about what kind of rests energize me. And it's like being out with friends and, going on a road trip for a day. Yeah, I'm being more active and I'm doing stuff, but I come home so refreshed after that. So I could lay in bed all day or I could, do the road trip, see my friends, everything, and I would kind of be in the same situation. Because on those rest days, like I'd try to work, but I wouldn't get a lot done, right? And I thought I would feel guiltier going hanging out with my friends or doing something that I really wanted to do and not working, but I didn't, and I came back refreshed. And then on Sunday, I was able to actually put in some extra work on this YouTube channel or something like that. So that really helped me. And I really liked what they talked about there also, like micro rest and macro rest. So stepping away from your computer every 50 minutes. I don't always do that. So I tend to get very like caught up in certain problems, especially if I'm working on a deep technical problem. I need like 2, 3 hours of focus time with no interruptions. But they talked about like little tips about green space, right? Our brain relaxes with green space. So take a walk in a park if you can. When I was working in San Francisco in the city, there's not a ton of green space. They actually constructed Salesforce Park, which is near my office, and that was fantastic. I could actually like go walk around, or up at Lawrence Berkeley Lab, amazing nature. You could step outside 20 minutes, take a walk, feel great. But they actually did research that even looking at pictures of nature on your phone kind of help with that. It just activates something. So I followed a bunch of Instagram accounts with like travel, beautiful travel locations, stuff like that. So that's where I started out. And then I started building kind of habits that help me. So the pandemic was pretty hard for me. I mean, it's still going on, but not having workouts. And I realized how much I anchored my day on working out. So when I was back at the office, I would try and work out pretty much every morning before work in some way. And not having that just was tough. And I'm back at it now, which I feel like like it sets me up for success for the rest of the day, instead of staying in bed and being lazy or just like, it gets me up, it gets me active, it gets my blood flowing. Um, which helps a lot. I also have a dog, so that also has helped kind of anchor me, like for the beginning of the workday and end of the workday, right? So walking him before work, walking him after work, it's like, okay, I'm going to shut my laptop, be done with this, take a mental break. So having those anchors and kind of getting the blood flowing and everything has helped. And I'm very I'm the type of person that I sometimes push myself into completing certain things. I I use Workflowy, so that's been my best thing to like keep track of everything I have to do and mental energy. So I fall asleep great actually, just because I know everything's written in my document and I'm never going to forget about it. And what I do is I have the Scribbles document or Scribbles bullet point, and I just like write down all the tasks that I need to do. And then every week I kind of plan out what I can feasibly get done in that kind of day. And so I'll put down like, okay, so I have a workout class on Monday, and I'll kind of split that into daily bullet points and do all that. And I prioritize in a way where it's like, if I don't get anything, if I don't get that done, that's fine. I try not overload myself because I'm always like, I can always go to the next day and like grab something from that task if I really want to. Um, yeah, so for me, it's been a lot more about understanding the rest part and the flexibility. And that has been kind of an important part of keeping me from burnout. And then also macro rest in that I need to take more weeks off, just completely off and relax and not work. Go to a nice, take a nice vacation. I was not good about taking vacations ever, and I'm still not great because we're in a pandemic, right? But I want to get better at that and actually taking the time off. So I focus on that. So yesterday I kind of had a bad week this week, and I was exhausted, and I was like, I need to get the script done. I need to get this done. I have an appointment I have to do. I have a workout. I went to the workout and I realized, like, you know what? I'm feeling stressed. I'm feeling burnt out. So instead, I was like, you know what? I'm not going to work today. And I texted a friend to get lunch in the city because I knew I was going to be there for an appointment. I just spent the day kind of hanging out. And then in the evening, I actually worked a little bit because I was feeling refreshed that from that. And sometimes honestly, if things aren't working, like if I'm working on a deep technical problem and I'm like my brain is tired, I won't do it. Like I'll step away. I'd rather step away, at 3 p.m., walk the dog, do something else, do something I enjoy, and then I'll feel much better and I'll actually be able to come back to it and actually do something instead of staring at my screen for 2 extra hours and not getting anything done.
Hmm. Actually, that last point that you brought up reminds me that although some really bad things have happened because of COVID, one of the good things is that not only tech industry, but also all the other industries see that actually people don't have to stay, 9 to 5, but you have to trust your employees so that if they don't feel like working, maybe just let them rest and do a thing later.
Yeah, definitely. I've always kind of done that even pre-pandemic. There's yeah, my company has always been pretty good about that, but yeah, a lot more people are discovering that that's way better for efficiency, and I'm lucky that the people around me really encourage taking real rest, and actually they're role models in taking that rest. It's one thing for, your boss to say, yeah, you should take a vacation. It's another one to see your boss every 3 months on the dot, take a week off. That normalizes it. That means you can do that as well.
See, people, I'm now talking to the listeners, but this is exactly why I want to promote those ideas in this channel, because I felt it as a developer. I've burned out because I'm just working, but in the end you have to listen to your body, to your mental state, and you have to forgive yourself if you can't feel bad because you have run out of energy. It's just your body telling you that, hey, let's take a break.
Yeah, it's time to take a break, do something else. And yeah, I had a pretty bad migraine issues this year. So I've already had migraines in my life, but they got a lot worse just because you could only really be on your computer, if you couldn't go anywhere. And having to solve that. And they trigger for me if I, overwork. And yeah, it's made me a lot more conscious about, all the tools that I have, all the rest that I need to take. And I'm much more efficient, honestly, than I was when I was, on the computer 12 hours a day, working on things because I have the energy to do it. And that's Cal Newport's blog, or one of his books talks about that as well. So I really enjoyed that. I started reading it in college, where he has a chart of like focus. It's like the first hour you're like a 10 out of 10 focus, second hour is 9 out of 10, third hour you're like a 5 out of 10, fourth hour is like a 2 out of 10. So why don't you just do 2 hours, take a break, come back and do 2 more hours, then in hours you'll have completed more, 4 hours total with like two chunks, you'll have completed more in that time than you would with like 10 to 12 hours. So
Mm-hmm.
that helps when you fit stuff in. So I'm very cognizant of like how I'm feeling and self-awareness, because I know that, okay, even if I don't want to do it now, like if I'm not feeling doing it now, I'll feel better if I do something that's not like lazing around or on computer, or do something to actually refresh my energy. I can do that same thing in like 20 minutes later, right? And that's a hard thing to develop, self-awareness, and kind of, if you're at a job, sometimes you feel a little like, I can't step away from my computer for 20, 30 minutes. For my team, we said, you know what, here's a rule: during work hours, do anything you want, just type like AFK 30 minutes or 40 minutes or whatever. Like, fine. Like, we'd rather have you do that, just like so we know that you're AFK, so we're not like, something has happened or something, something crazy is going on. And then, if something really blows up, they can always call you and interrupt that thing, which never has happened, right? But at least you just set the expectation like, hey, I need a break. I'm taking that break, and leave me alone for 30 minutes.
These are the kind of topics I feel we could talk about for ages, because there are so many important topics to discuss. By the way, the book that you mentioned by Carl Newport, is it so good that that you can't they can't
Can't
ignore you?
ignore you? Yes. So the two of my holy grail books from his collection is So Good They Can't Ignore You, and then Deep Work. So Deep Work is one that's a little more advanced, I think. So Good They Can't Ignore You, like, talks more about that passion and figuring out what you want to do and becoming good at it and getting that happiness from that. Deep Work actually talks about a lot more practical skills. So about 4 years ago, I realized that due to all the distractions in the world, like, I wasn't focusing really well. I didn't have that 10 out of 10 first hour energy. I was like 5 out of 10 maximum, because of, I had an Apple Watch at the point. I still have it, but I don't wear it as often, turned off all the notifications. And one of the exercises was like, take the thing that you have to do, leave your cell phone and walk into the woods, like, 30 minutes into the woods, and sit there for an hour. I don't care if you don't do anything. You can just sit and stare at the, trees for an hour. But likely, if you don't have those distractions, you're actually going to do the thing that's in front of you. And it helped kind of retrain me and reset me back to the mode where I could do the same thing at home. But it took a few of these practice exercises. I understood that there's so many distractions in my life, and you got to really just set boundaries on that, which I feel for me, I'm able to, just being later in the career, I think you get a little more confidence to just say these sort of things. But I'll be like, look, the worst thing in my life is when you have meetings with like 30-minute gaps in between them. I cannot function if I have a day like that. And if
Totally
it's an
agree, by
8 hour
the way.
chunk, like, it's so bad. I can't get deep into like any good coding with just 30 minutes. Like, maybe I'll do a code review, or I can, quickly correct something, but deep, deep work I can't do. And so I've worked only like 4 or 5 hours that day, right? But I've gotten nothing done because of these gaps, versus like, if I had a meeting with like if I had a day with 4 hours of meeting, which I don't often have, but they're all in the morning, then I have that chunk of time in the afternoon, those 2, 3 hours, where I can really get deep on something. Like, and I can actually get something done during that time. So I've been pretty happy that my, situation allows me to say like, hey, like, can we shift this? Like, can we adapt this? Like, this is not a good day. And if I have to do it, then I just, a lot of people understand. A lot of people like you understand this 30-minute gap. And you're just like, I got a lot of like little things done yesterday, but I didn't get any huge coding done. And that's okay, because that's just the situation we're in. But I'm very lucky being able to kind of set my schedule in that way, and really truly adapt it to my own needs. And that's super helpful. Here in Silicon Valley, people are very flexible with engineers, so that's been good to just be able to start working when I need to, take breaks when I need to, um, you know take a walk when I need to.
Hmm. I guess also regarding those, I don't know how to say it, like mindfulness and topics around it. it has become more popular both in tech but other industries because we have so many great authors, you know, sharing their ideas and kind of ways of how you can tackle it. And also, like if you are maybe less experienced or you're just starting out in your career, I remember I was like, yeah, burnout. Come on, I'm not going to burn out. I love coding. But once you experience it, you start to understand it. And it kind of you have to educate yourself about those topics.
Yeah, and as you know, the better you get at code, the less you actually code. I feel like half of my
Yeah,
life right now is spent in grooming meetings and like architecture and design. And I'm sitting there being like, I want to get back to. I had a week recently where the first line of code I wrote was like on a Thursday afternoon, and I was so happy to do that. But yeah, you start getting away from it a little bit and getting through all the meetings, and yeah, the burnout happens.
as you deal with quantum computers, and I've also seen you made videos about AI and so on. I need to ask, what do you believe are the future technologies that are going to impact us the most?
Well, I do hope quantum computing is one of those because I'm really excited about the impacts, right? So, one of the big near term applications is quantum chemistry, which doesn't sound super interesting until you realize that chemistry can affect, medicine discovery. It can affect materials, right? You go, okay, well, why does a material matter? Well, right now, there's a lot of things limiting, for example, like airplane speed, where materials could help out. So, one of the things is like, if heat gets too high, the materials will melt, right? What if we can make a better material to stand up to heat? Something like that. What if we can make more efficient fuel? All these things are in the end, quantum chemistry applications. So that would be huge. Medicine, obviously, it's like huge there. So I'm really excited about that. I'm also excited that that's like a near term application instead of something, you know, 10 million qubits away. This is something that we kind of are seeing in our grasp. And if we can do that, that would be amazing. So I do hope that's one of those technologies. And I think because even though we have very few quantum algorithms, the applications are so broad that if we can do this, this is a game changer. Like honestly, I think this is a game changer technology. So that's why I'm kind of excited about it. It also feels a little bit like, early Silicon Valley, Fairchild semiconductor era, like a lot of physicists like in the lab and engineers like trying to figure out what it is, like punch cards. And yeah, so that's one of those. ML I do like. I think there's been a huge amount of applications there for that. I feel like I don't know. I've started reading and I've read some topics in the past on like universal artificial intelligence, right? And all those things. It's kind of terrifying, right? It's a little bit scary. Um, I still haven't developed an opinion on it. Like if we can do that, I have a lot of friends in neuroscience and we talk a lot about, quantum computing applied to neuroscience and ML AI. They tend to err towards the side of neural nets are a good like a good abstraction, but they're not the end game there. So I think if we can find something to like truly be able to map out the brain, that would be incredible. Like that'd be the next leap. I don't think neural nets are the thing yet to actually be able to map our brain. Just because of the amount of the brain processes so much data. Like that's
Mm.
so terrifying and scary there. Let me see what other technologies. I'm Yeah, I mean, I'm really excited about this whole lab grown meat thing because I think that's kind of starting this whole new industry here, climate change, but it could also go into medicine and other things there. I think that's super exciting. Um, I think that's gonna change, the face of what the future looks like for us. I hope that'll be normalized, that's kind of the world we live in, if it's safe and everything. But um, yeah, those are kind of my thoughts on the general topics. I don't know if you had any others you had specifically had questions for me on, in my opinion.
Well, as we are here and you've made a video about quantum computers and Bitcoin, I also have
Oh,
to ask. What's your take on blockchain as a technology, and do you see like decentralization uh, becoming
S-
something more popular in the future?
So I do think that Bitcoin is here to I think cryptocurrencies are here to stay. Whether it's Bitcoin, whether it's something else. I mean, I'm very impressed at this point with how well Bitcoin has done being a V0 of this entire proof of concept, right? I mean, the paper was brilliant. I tell a lot of people who are into this to go read it's not really an academic paper. It's like, what, 3 pages or something? It is incredible. It's super precise, super simple, and it breaks things down so well that I'm very excited about that being, around for a long time, and I think it will be. For applications outside of Bitcoin, I talked to a professor about this that I was working with at Coursera on blockchain stuff, and he said, like, I've never found an application for blockchain that a database can't do just as well, right? Bitcoin is really that application, but beyond that, we haven't really found anything else that really like needs the blockchain. So yeah, I do think cryptocurrencies are here to stay. I'm very excited about that. But I like the blockchain itself, like I think we really need to find like real applications for it that are much more useful. I mean, you can do a lot of things on it, but is it better than something simpler, right? And then you think about all the impacts that a lot of talk right now, Bitcoin on, climate change and the amount of energy it uses. So I think in the end, it will shift. It will look different, but I think it is here to stay.
Hmm. I guess it goes with all the technologies that you just mentioned. That when in the beginning we as people want to kind of use technologies for the problems that may not need those technologies, just to,
Right.
test out and try things out. But okay, let's leave those technical topics aside, and now I'm going to ask you 3 books that you recommend to other developers and tech people out there.
Ooh, well, I already mentioned three, I think, during this talk, which I definitely think everyone should look at, but I'll give you some bonuses after that. So definitely So Good They Can't Ignore You, Cal Newport, Deep Work, Cal Newport, and that Peak Performance book that really talks about rest. Incredible. Those three have really changed my life. I reread them pretty often. For developers, one of the best books I've read is there's two of them I was handed when I first became a software engineer. One's called Clean Code, which I think was really great because you didn't never really learn how to do that. And then Working with Legacy Code, which I thought was really funny considering our code base was like 5 years old. It's like that's already legacy code. We're not talking like COBOL or anything like crazy like that. We're just talking about like 5-year-old code. But I thought that those were really good resources, and they still are. I flip open to them every now and then and try and become a better developer. I think that those two have really helped me out in my software engineering career. That people don't think about those skills outside of the pure coding, but how do you make your code scalable? And as a physicist, for me, I also came from a background where I did a lot more procedural programming, and this is something that my lead actually mentioned a lot. Is like I worked with physicists a lot; they program in a different way, and it helped me kind of reshift my thinking into a more functional programming paradigm, which is more how computer scientists are actually taught. So I had to kind of transition, and that book kind of helped me understand like a lot of aspects of like scalability and design and things like that to move me into the correct direction, because my code worked, but when you're talking about a code base with hundreds of people, thousands of people developing on the same thing, like something that has less lines is not necessarily better, right? We had this problem at my old job where the backend was written in Scala. Great, Scala is brilliant. The people that write Scala are brilliant. No one can read that line of code after you're done with it, right? And so, sometimes breaking things down, making them more verbose, or you know, packaging things differently is something that I had to learn, and I think those two books really helped with that.
these are some great recommendations, some of which I am yet to read, but some of which I truly agree with. I guess this is a really nice place to finish this conversation. But Anastasia, I'm like super thankful for taking this time to talk about all the interesting topics. And to all the listeners, if you want to learn more about software engineering, quantum computing, or some other tech related topics, then definitely go look at Anastasia's YouTube channel. I'm gonna add a link in the description of this video. And yeah, thank you, Anastasia.
Thank you so much for having me.